Hi folks, welcome back to Physics with Captain Rod. I'm just making this video to help you students with your physics homework here. All right, I'm just going to go through these one at a time. This is homework set number 2. And first one says, let's see, mass of an elephant is 26,667 kilograms. Now, depending on the class you're in, some of you may have different numbers than this. However, everybody's given a value, and it says to find the elephant's weight in newtons. So weight is the force of gravity is equal to mg. The value mass is given. The value for g is 9.8 meter over second squared for everyone, and that's all there is to part A. For part B, where it says find its weight in pounds, that's going to be unit conversion. Once you get this number, it will come out in newtons. Then what you'll do is look up a conversion factor between newtons and pounds, and I'm not going to tell you what that is. And then it's just do the unit conversion on it. And again, if you don't remember how to do unit conversions, go back and take a look at my video on how to convert units. All right, number 2. Number 2 says a motorcycle and rider have a total mass equal to 270 kilograms. Now mine says 270 kilograms, and again, depending on what class you're on, you may have a different number than that. The rider applies the brakes and accelerates at -4 meter per second squared. And again, depending on the class you're in, you may have a different number there, but you will have a number. So when it says what is the net force on the motorcycle, this is a Newton's second law question. Net force equals mass times acceleration. The mass is given, and so is the acceleration. You'll notice that if you follow the minus sign through, you'll get a negative number for the net force, and that just means opposite the direction that the motorcycle is going. Number 3, it says in an experiment in a space station, a force of 80 newtons causes an acceleration of 3 meter per second squared. So again, depending on the class you're in, you may have different values here and here, but you will have values. And to find the object's mass, we can write out Newton's second law, F equals ma. Now, the fact that it's in a space station is somewhat relevant. This is the only force acting on this object. Therefore, this is the net force, and then the acceleration is given, and then you solve for the mass. All right, number 4. And number 4 is one that gives people some trouble, so I'm going to take a moment here and kind of sketch this. So we've got this elevator, and I think what I'll do here is I think I'll pause this for a moment and draw a decent sketch. Okay, folks, I'm back. So I got a little bit of a sketch here similar to what you see in number 4. The idea here is that we got this person, and they're sitting in an elevator, and they're standing on some sort of scale. Now, a scale, what it actually reads, it doesn't directly read your weight. What it reads is the force interaction between your feet and the scale. And the force that the scale puts onto this person is up. And that's example of what's called a normal force. And then the person's weight is a force vector that's down. And we normally calculate a weight by mg. These are the two forces acting on the person. The net force is the vector sum of the two. So that's going to be this force minus the mg. So that would be the normal minus mg. And by Newton's second law, that force is equal to ma. So again, Newton's second law is net force equals mass times acceleration. But again, the F in Newton's second law is the net force. So that's going to be the force from the scale on the person, and then minus the weight of the person, minus because this force points down. Now this is called a normal force. If you want to call it like force from the scale or something like that, force from the scale minus mg equals ma, that's perfectly fine. And in this problem it says the scale, when the elevator's at rest, the scale reads 802 newtons. And again, depending on the class, you may see a different number there. If the elevator is at rest, there is no acceleration. And if we look at this equation there, this would be 0 if it's at rest, and you can, or this would be 0, and you could solve for the mass. So you'd put the 802 newtons under the scale force minus m, and then gravity is 9.8 meter per second squared. And then you solve that for the mass. Part B, the elevator is accelerating upward at 4 meter per second squared. So in part B, right? This equation is still valid, except this isn't 0 now. You're going to put the acceleration in that spot. The mass that you found from part A will go here, and then you can find the new scale force. Part C, where it says the elevator moves at a steady speed, right? If the elevator speed is steady, that means there's no acceleration. And again, these two forces would be equal. And the mass you found from the first part. So I'm going to call that enough on number 4 here. Again, I can make another video if that's still giving folks trouble. Talk about number 5. A jet aircraft with a mass of 4,350 kilograms. So I got 4,350 kilograms. Now again, depending on the class you're in, you may have a different number here, but you still will have a number. Just write down whatever number you have. Let's see, the engine exerts a force equal to 59,800 newtons. So part A says, what is the acceleration? So use Newton's second law. Force equals mass times acceleration. They give you a force. They give you a mass. Then you can solve for the acceleration. Parts B and C are motion questions. If you read them, one says, how fast will it go after 6 seconds, and the other is how far. So I would start this like we start most of these motion questions. Graph velocity against time. Now, presumably at t equals 0, the jet is not moving yet. And then sometime later, in fact, in this question it says 6 seconds, so 1, 2, 3, 4, 5, 6. The jet is going a certain velocity that we don't know, so we might label it something like v final. And again, connect the dots. So now the slope, which is rise over run, that would equal v final over 6 seconds, is equal to the acceleration that we found from part A. And then to get the distance traveled, that's a delta x, that's going to equal this area. So once you have the v final, this is a triangle, 1/2 base times height will give you the distance that jet travels. So I think I'm going to call that a day here as far as this particular video. I can make more videos later to answer some more of these questions. Hope this gets everyone rolling on their homework. Have a great day.